guys, today we're going to start with net ionics. And what a net ionic equation is looking at an equation and taking out spectator ions. Spectator ions, just like a spectator of a sport, are things that are people that don't participate. Spectator ions are ions that are just floating around, not really participating in the reaction. They're just kind of hanging out and not really doing much of anything. So if you can maybe or may not remember, in pre-AP I set up two beakers up on my lab station. In those two beakers, in one of them I put sugar. The formula for sugar is C12H22O11. And I drop some sugar down in the water. And of course the sugar dissolved, because we know that the sugar will dissolve in water. And then in the other beaker I put some sodium chloride, which is just salt. And then I put that in the water. And of course salt will do what? It will also dissolve. Then I took an electrode and I put it in each one that had a little light bulb attached. And one of them lit up and one of them didn't. The one that lit up was the sodium chloride. The one that didn't was the sugar. The difference being is that sodium chloride is an ionic compound, and when I put it in water it does something very special. And one thing it will do is conduct electricity, making it something called an electrolyte, which is the substance that dissolves in water and will conduct electricity. Sugar, on the other hand, being covalent, is a non-electrolyte. It does not break into ions and does not conduct electricity. So these are molecules, and if we looked in this little drop of sugar there might be like 1,000,000 molecules. And in this speck of salt, we'll say there's 1,000,000 of those. And they're both dissolving, but they're not called molecules here, they're called formula units. And here's the difference. When this guy breaks up, those millions, just like if you had 1,000,000 people and you just told them to disperse, they start breaking apart from one another, but their people still stay as people. And so this still stays as C12H22O11. The compound still stays together. The reason you can't see it or it dissolves is because instead of being now 1,000,000 molecules, you may have 2 or 3 molecules still stuck together. But the main thing is that they stick together, so I put a box around them, because in a moment we're going to be talking about boxing things and slashing things. Well, if I put a box around them, that means the compound stays together when put in water. Salt, on the other hand, actually breaks apart. The sodium comes apart, the sodium ions come apart from the chlorine ions. They become charged particles, and this is the reason sodium chloride can conduct electricity. The sodium and the chlorine separate from one another. Now notice this is chlorine ions, which is actually called chloride, and so it's not Cl2 because it's not chlorine the gas, but chlorine the ion called chloride. So they break apart, and this will conduct electricity. Now, this is called an electrolyte. This is a non-electrolyte. This one I kept together. This one I broke apart. And the difference is this is covalent. This is ionic. So we're about to start talking about net ionic rules, and net ionic rules apply to ionic compounds only. If you were absent today, I have put a copy of the notes here on Edmodo, and so you can copy that. Unfortunately, the back side of the notes you'll have to come get from me. It has a chart on the back. For the most part, you can figure this out with the front side. If you're watching this again for the second side, for the second time, then you should have the set of notes. Alright, we are working off the net ionic practice sheet that was given back to you for your homework. We're going to start with number 2. Number 2 had sodium carbonate plus barium nitrate, making sodium nitrate or barium carbonate. What we're going to do is look at our net ionic sheet, and we're going to follow the rules. It's got 4 steps to it, and we're going to follow them in order. And we're going to decide if each compound will stay together or whether it break apart when I put it in water. If you'll look at number 1, this is the number 2 problem, but if you'll look on the net ionic worksheet, the rules, and if you were absent, you can download that, because I did upload it to Edmodo. First thing it says, is this compound an acid? And is sodium carbonate an acid? Of course, it's not an acid. An acid would end with the word acid, or it would have a hydrogen to begin with. This is not an acid. So in the thing it says, if no, go to 2. Number 2 says, is the compound a hydroxide base? Sodium carbonate does not have hydroxide, so no, it is not. On the sheet it says, if no, go to number 3. Number 3 says, is this an ionic compound? The answer is yes. This is an ionic compound because there's that metal and there's that polyatomic ion. So now I need to look at the bullets that are underneath number 3. The first bullet says / all nitrate. Well, this is not a nitrate compound. But the second one says / all alkali metals. If we look at sodium under the periodic table, it is an alkali metal. That means sodium carbonate compound is actually going to break apart. Just like sodium chloride ion breaks apart into its ions, this guy's going to break apart into his ions. To illustrate that, we draw a line between the sodium and the carbonate, and we put their charges, what their charges are going to be when they form their ions. Sodium's going to form a +1 ion, carbonate's going to make a -2 ion. Because they're going to be charged particles dissolved in water, we label them aqueous. Aqueous means charged particles dissolved in water. Aqueous. All right, we go to the next one. Looking through the same rules. This is not an acid, so we go to 2. It's not a hydroxide base, so we go to 3. This is an ionic compound, and it says / all nitrate, so we're going to /. If we put a /, we're going to put their charges above them, and we're going to label this AQ. Means that this will dissolve in water. On to the next one. We've got sodium nitrate. Well, for the same reasons we slashed together, you will see why nitrate is my favorite. He will always / because sodium is in the first family, nitrate is always /. We're going to put their charges, and we're going to label it aqueous. Now we look at this one. Is it an acid? No. Is it a base? No. Is it an ionic compound? Yes. Now we go through the rules. / all nitrates doesn't apply. Alkali metals doesn't apply. Ammonium acetate, perchlorate, or chlorate, none of those apply. / all chlorides, bromides, or iodides doesn't apply. / all sulfates doesn't apply. So then we read the next, number 4. All other compounds will be boxed. So we're going to box this guy. Since it's an ionic compound, we are going to label this a solid. Once you've done your boxing and slashing, you're now ready to get rid of spectator ions. The way you know that they're spectator ions is in the beginning, before the reaction, on the reactant side, they were just kind of hanging out. When I put a / by them, that means in the beaker, all they were doing was hanging out in the beaker as ions. And I'm writing 2 of these because there is Na2. And so this guy was just hanging out in the beaker, and this guy is just kind of hanging out in the beaker. There are double the nitrates to the barium. They're just hanging out in the beaker. When I put this together and we got a reaction, the sodium's still just hanging out. The nitrate's still just hanging out. How do I know? Because I've got a / through it. Aqueous means dissolved in water and has the charges. And what's going to happen to the barium carbonate? Well, he actually formed a solid, and no longer is just hanging out. They just actually joined up together, kind of like made a couple there. So to the spectators, hopefully you can see them here, is these sodiums here are spectating. They're just hanging out before and hanging out after. And these nitrates are also spectating, just hanging out before and hanging out afterwards. But you don't have to draw those pictures out to see it. You can look up here in your reaction, and if you'll notice, if before and after they're never ever in a box, then they're a spectator. Here's sodium, there's sodium. Sodium is a spectator. We're going to put a big S on them for spectating, meaning they're just hanging out, not really doing anything. Carbonates here was a spectating in the beginning, and now he actually did something. So it's not a spectator. Barium is also not a spectator because it's in the box over here. So nitrate, on the other hand, love nitrate, but nitrate's always just spectating. So once I've got it chopped up, labeled, and now I've got my S's on there, I'm ready to now write only the net ionic equation. And what the net ionic equation is taking out the spectators. The spectators are really there, just like the spectators are at a sport. But we don't want to zoom in on them, so we're just not going to look at them. And we write down everything else. So carbonate is aqueous, dissolved in water. It does have a charge. Barium does have a charge, is also aqueous. And then barium carbonate is our solid. And this is called the net ionic. Notice the thing with the box does not have a charge on it. This is the net ionic. Moving to example 2. Okay, this is not an acid, not a base. Lithium is in the first family. This is actually number 3 on your worksheet. We're going to plot +1, -1. We're going to label it aqueous. We are slashing because this is an alkali metal or because that's a bromide. There's nitrate again. Love nitrate. He's always going to slash on us. There's nitrate again. So we're going to slash and put aqueous. There is a rule about slashing all bromides, but there's an exception. You got to keep reading on this one. This is where you have to memorize this stuff. If you took pre-AP with me last year, I made you memorize it. Seniors, I didn't, but now you have to. It said that lead and silver are exceptions with this, and this is silver bromide. It says box it, and we're going to label it a solid. So now we're going to get rid of our spectators. Lithium is here, lithium's over there, never in a box, so lithium's a spectator. Bromine's here, bromine's over there in a box, so he's not spectating. Silver's not spectating. Nitrate, big old spectator. So we got bromine, which is actually called bromide because he's in ion form, plus silver as an ion is going to make silver bromide a solid. And there's our answer for number 3. The reason I started with number 2 is because number 1 and number 4 are single replacement reactions. They're kind of special. You actually have to look on an activity series to see whether or not a single replacement will take place. If you were in class, on the back of your net ionic notes, there is an activity series. You don't have to memorize that. You just need to know how to be able to use it. You have to see whether or not this reaction is going to happen. If you were absent from class, you could look up activity series in your book, or you can wait till you get to class and get one from me. These are only used on single replacement reactions, so none of the others apply. You have to look to see if this solid piece of metal is more active and will kick out the other one. And those of you that were in class and see, if you look at on your activity series, that iron is actually higher up and more active than lead, so this reaction will take place. So if it will take place, we're going to do the net ionics. First off, this is not an acid, it's not a base. It's actually also not an ionic compound. It's a piece of iron. So we're going to put a box around him, and we put a box, we're going to label him solid. What are we going to do with this guy? Well, that's a nitrate, so I'm going to slash him. I'm going to put their charges, and I'm going to label it aqueous. There's nitrate again. I'm going to slash him, and I'm going to put their charges and label him aqueous. This is not an acid, not a base, not an ionic compound, so this would get boxed and it would get labeled a solid. If we get rid of our spectators, which is that nitrate, I can't get rid of the iron because he's in a box over here. Can't get rid of the lead because he's in a box over there. So I'm going to write it. Notice this Fe does not have a charge on it because when it's solid, it's not charged. Then Pb is actually charged because it's not solid, it's aqueous. It's going to make iron that's not solid, it's actually aqueous, and change it to lead that is solid. This is not a no reaction because something's really happening. This solid is going into solution, and this solution is going into a solid. And that is a single replacement reaction. Number 4. If we look at our activity series, nickel is lower on the totem pole than sodium, so this reaction is not going to take place. Even though I can write it, it really is what we call a no reaction. And the reason is it's a no reaction. Nickel doesn't have enough activity to kick out the sodium, so it's not going to happen. Sodium's liking the fact that he's an ion. Okay. I think the last example I have on this one is number 13 that's on the back. If we go through our rules, this is not an acid, this is not a base, this is not an ionic compound. This is actually hexane, which is a gas. If we go through this one, this is not an acid, it's not a base, it's not an ionic compound. Oxygen is actually a gas. This one is not an acid, it's not a base, it's not an ionic compound, so it gets boxed. Carbon dioxide actually is a gas. This is not an acid, it's not a base, it's not an ionic compound. Water is actually a liquid. And so this is not a no reaction, this is actually the real reaction of that one. We don't use net ionics for covalent compounds. So this reaction would be looks just like this. But I wanted to show you that the key can still work even though you weren't sure about ionic or not. It will work. So if it's a combustion reaction, you should love them because you don't really have to net ionic them because they're going to be just what they say they are. Hopefully this helped for some of you that are watching this, and hopefully it helps someone. If you are watching this, if you'll at least just tell me that you are, that way I know I'm not spending my Friday afternoon doing this for nothing. So just tell me one day or send me a note on Edmodo that this might have helped you, and that way I'll continue to tape these as I can. Okay, you guys have a great weekend.